In this one, we have z is a standard normal random variable with a mean of 0 and a standard deviation or variance of 1. And it says find x so that the probability of the absolute value of z is greater than or equal to x is equal to 0.42. And this absolute value is what seems to throw people off. Okay, so you have absolute value is greater than or equal to. This means you're kind of looking at the tails. Or it means that z is less than or equal to negative x, or z is greater than or equal to positive x. Or if we were to draw it on our normal curve, if this is negative x and here's x, then we're looking at the two tails. So either less than the negative x or greater than the positive x. So what you're saying is these two tails together have to equal 0.42. There's no way to just look that up on our table, but you could say, okay, this should be symmetrical. That's negative x, this is positive x. So we should be able to just divide that by 2. So 0.42 divided by 2 is 0.21. So we should have 0.21 in each tail. So let's look up a 0.21 probability. Okay, so pull up your normal table. We're looking for 0.21 and the area. The areas are in the middle, so look in the middle for 0.21. It looks like this is the closest, so z is going to be about negative 0.81. So this z value is negative 0.81, which means this z value would be positive 0.81. Now, our textbook said put a little x there. I like a z, but they did say x. So for this statement to hold true, then this means our final answer, x, would be equal to 0.81. And we went with the positive one because for an absolute value to be bigger than it, it would have to be the positive one.